Alright, this video begins our second lesson in Unit 1, and in this lesson we'll be dealing with absolute value inequalities. And this is part 1 of this lesson. Our objective in this lesson is going to be to write, solve, and graph absolute value inequalities. This is our vocabulary. You need to write this information down and make sure you understand how to use these terms. So pause the video and write this information down. Alright, our mission in this particular lesson is we're going to be solving an absolute value inequality that has the absolute value bars, the absolute value symbol, and it will also have the less than or the less than or equal to symbol. An example of this is the absolute value of x. X is inside the absolute value bars is less than 3. What that means is any answer that you substitute in for x will work as long as it is bigger than -3 but smaller than 3. This is our first example. And what I want you to do, your directions in this are to solve, graph, and write in set builder and interval notation. Alright, to solve an absolute value inequality, your first objective is to make sure your absolute value bars and what's inside of them, just inside the absolute value bars, and the only thing on one side of the inequality. And if you will look up here, I have absolute value bars and a 2x minus 1 inside the bars. There's nothing outside the bars. So once it's in that form, you can go on to your next step. And your next step is to take what's inside the bars, this 2x minus 1, and write it twice. Write it once, make a copy. The first time you write it down, you keep everything outside the bars. The second time, you flip everything that comes after the bars. Your inequality changes direction, and your sign flips on whatever's outside. Now, absolute value and the less than symbol, I call it, less than. It's going to be less than. It's going to be an and compound inequality. So now you solve it just like you would an and compound inequality. You're going to solve both inequalities individually, undo your with addition. So you're going to add 1 to each side. Then your inequality looks like this. You undo your multiplication with division. So your answer is x is less than 3. Now we're going to solve the second inequality. And you'll notice here, I wrote 2x minus 1 down twice. So I will follow the exact same steps to solve the second inequality. It's just I'm going to come up with a different answer this time. My 1's cancel out. I'm left with 2x. And -5 plus 1 is a -4. Now I'm going to undo my multiplication with division. So my answer here is x is greater than -2. And remember, I have an and in between them. So when I graph this, what this means is x has to be, I'm going to start at -2, 1, 0, 1, 2, 3. First of all, I'm going to have, since I take the same symbol and I just flip it, both my dots are open. So I'm going to have open dots at 2 and 3. And if you look at the inequality here in red, it says x has to be bigger than -2. So it's going to be shaded that way. And if you look at my inequality here in blue, it says x has to be smaller than 3. Now if I look at these two lines up here, my red and blue line, the only place where they overlap is in between the two numbers. So let's see, let me change that color a little bit. So my shading is going to be right here, in between those two numbers, the green there. Alright, now my interval notation. My interval notation is just start point, comma, stop point of shading. My shading starts at -2 and it stops at 3. No closed dots, so everything has a parenthesis. And I can write my set builder notation here. I can actually, it's two ways you can go about this. It is a set of all real numbers x such that, and I can rewrite my answer over there as 3, and I can do an and, or I can do this little end symbol there. That means intersection. And is the intersection if you've ever done sets. And x is greater than -2. Or I could write this as the set of all real numbers x such that, and I could say x is in between -2 and 3. And that's my answers. Alright, here's the next problem. Now this problem I want you to work on your own, but here there's something I need to tell you about. Our first step was to make sure the bars were by themselves on one side of the equal sign. And if you look right here, they're not by themselves. I have that +3 hanging around outside, and I've got to get rid of it. So think about, how could you get rid of that? You have to get rid of that 3 before you can write it twice. So pause the video, think about this, and let's work this out. Alright, I'm going to give you the answers here so you can check your work. I came up with, and you always should double check me because I'm not always right, y is less than or equal to 6, and y is greater than or equal to -2. When I graph that on the number line, I have -2, I have 6, I'm going to have closed dots at both, and this says it has to be bigger than -2, and my other one says it has to be smaller than 6. So the only two places where this line and this line overlap each other is in between. So I shade the area in between. And my interval notation, shading, start point, comma, stop point. So I start at -2, I stop at 6. Close dots on both, so brackets on both. And my set builder notation, for all real numbers y such that, and I'm just going to say y is between -2 and 6. Alright, this is your final problem. I want you to try this one on your own. One thing I want you to do is we are going to change the problem. I want you, when you do the problem, instead of a +2, I want you to have a -2 there. Alright, now you're going to do this problem on your own. It's a little bit more complicated, but I do believe you're up to the challenge. Two things to keep in mind. We have this -2 here, and we're going to have to get rid of it. And we have that multiplication of 1/4 out there in front. It has to be gotten rid of before you can write it twice. So keep those things in mind, and good luck, and you'll be answering a question or two about this on Google Forms. Alright, and here's you something to think about. I'll read it to you. You got a friend who's planned a trip to Alaska, and he's purchased a coat that is recommended for outdoor temperatures from -15 degrees Fahrenheit to 45 degrees Fahrenheit. And it says, let T represent the temperature for which the coat is intended. You need to write an absolute value inequality to represent the situation, and you need to show me what that inequality would look like without using the absolute value bars. There may be a question about it on your Google form, and we will talk about it tomorrow. See you tomorrow.